Excelsior means Experimental Center for Large Spectrum Properties of Nanostructures from DC to Mid-Infrared, and be installed in the Institute of Electronic, Microelectronic, and Nanotechnology, IEMN, one of the largest jointed CNRS laboratory in the field of nanotechnology. The instruments purchased and developed within the Excelsior project have been recently gathered in a new building with 1,100 square meters of facilities, making IEMN a European gateway for the academic and industrial communities involved in a broad range of research activities, including nanoscience, materials, and microelectronics. This new space offers high performances, temperature stability, vibration level, and controlled dust level, ISO 8. Through the Excelsior project, we wanted to address new challenges facing metrology for the measurement of critical dimensions in materials science and devices extending beyond CMOS. Of particular importance was the need to integrate high-frequency signals from DC to mid-infrared into multiple probe near-field microscopy. The first Excelsior instrument is the high-frequency nanoprober. This unique instrument gathers several probing and imaging tools dedicated for broadband electrical characterization. The instrument was designed to probe nanomaterials and devices in the microwave range. It overcomes two bottlenecks: the dimensional and electrical mismatches between microwave instrumentation and device under test. The probe's motion is achieved through the use of 4 piezoelectric nanomanipulators, 2 for DC and 2 for HF, with displacement resolution higher than 10 nanometers. SEM navigation in controlled high-vacuum environment with sub-10 nanometers of resolution under low electrical field, with beam blanking options to limit the invasive action of electron beam on DUT, allows the precise positioning of the probes on a sample. External microwave instruments are connected to the probes with 40 GHz through pass connectors. In order to probe DUT with reduced area pads, several square micrometers, we have designed and fabricated, using IEMN cleanroom facilities, MEMS-based miniaturized 20 GHz GSG probes.
My thesis focuses on how to measure accurately properties of nano-device in the high-frequency domain. So, using the unique instruments at the international level, I can reach my scientific goals regarding to my thesis works.
The second part of the Excelsior project relies on 2 microscopes: a low-temperature atomic force microscope that has proven its potential to determine and change the charge states of atoms and molecules, and a multiple probe scanning tunneling microscope where the unique combination of 4 STM probe tips and a scanning electron microscope in ultra-high vacuum allows 4-point contact measurements and function testing of new materials and nanodevices. One major goal of the Excelsior project was to combine these scanning probe microscopes with a femtosecond resolution pulsed laser excitation system to probe electron dynamics with sub-nanometer spatial resolution. The technique relies on the measurement of a transient photocurrent with STM upon optical excitation of a sample with ultra-fast laser pulses. The successful control over the pulse delay modulation using pulse-picking techniques opens the way to visualize the transient carrier dynamics in nanometer scale structures with a temporal resolution below the picosecond. The third Excelsior instrument is a scattering scanning near-field optical microscope, SSNOM, associated with the mid-infrared quantum cascade laser source and an infrared detector. We have expanded the frequency range of this microscope with a terahertz molecular laser and an indium antimonide bolometer. This near-field microscope allows to record pictures of nano-objects or 2D materials as graphene with a few tens of nanometer of resolution in these particular frequency ranges that interact strongly with matter.
In Vmicro, a spin-off of IEMN, we developed high-performance sensors based on microsystems. Thanks to the Excelsior Equipex experimental setup, like the SEM nanoprober and the scanning optical microscope, which are unique in France, we were able to successfully characterize our future products. Having access to this equipment is a key factor for both accelerating our development and addressing new markets.